Hi, my name is Sheldon Foster and my partner is Solomon Pobe. We put together this presentation on the first way, the principles of flow. Our group is group number 8. In manufacturing, work is very visible. You can see the product move throughout the whole process, but this can be very slow. In technology, however, work tends to be invisible. The work can be moved along with just the click of a button, such as by reassigning a work ticket to another team. So one of the best methods of making work visible, which is one of the goals of the DevOps process and improving flow, is to use visual work boards, which are called Kanban boards, or sprint planning boards, where we can represent work on a physical or electronic card. Oftentimes this is used in companies using post-it notes. Here is an example of a Kanban board, and this helps us to make our work visible, and it helps us because we can start in each of these columns from the left moving toward the right, and we can track the work that we do. This work in the leftmost column is ready to be done, and as we move each of these pieces through the process of investigate, development, ops, and I know some companies label these columns differently, like work in progress, development, testing, so forth and so on. But as we move from left to right, each one of these columns represents a work center, and it only moves to the right once that portion of the work is complete. And when it reaches the final destination to the right of the board, it's usually in a column labeled Done or In Production. That's when that work is complete. And it's important that we limit the number of pieces of work in each of these columns. That will help us as well. Okay, that takes us to the next slide here. An important role of the work in process piece is to manage the amount of work that we have in any of these queues at any given time. By limiting the number of pieces of work, it helps us to see problems that prevent the completion of that work. It also limits multitasking between each of these columns. If a user has or a worker has too many pieces that they're working on, then they tend to multitask, and that causes production issues. So by limiting the number of work in each of these columns, workers tend to be more productive. Another way that we can improve lead time and flow is by reducing batch sizes. Now, in technology work, batch sizes can often refer to code, and by reducing the amount of work from a large project to smaller, more manageable projects, we can work on these pieces and get them done completely before we move on to the next one. And as you can see on this screen, on this graph here, if you take and do several pieces at once in each step, you don't end up having a first product ready until much later in the process. If you break down those pieces into each individual part, each individual type of work, and then do one piece at a time, it lets you get a product ready sooner, and then it also lets you see any kind of errors or problems with that first product that you can then fix earlier on. That way it only affects the current product that you made. So lead time for the first product is greatly reduced, and because you can eliminate errors, in the long run you will have better production and less problems and errors. Fewer problems and errors. Okay. Another way to increase flow is to reduce the number of handoffs. And what this means is when you look at that Kanban board and you look at those different columns, when we move a piece of code or a project through the process from, say, developer to tester and back and forth, it often requires a large degree of communication or steps, coordination and documentation. And oftentimes knowledge is lost when you have that back and forth. Either you miss the knowledge or it gets relayed incorrectly. So by reducing the number of handoffs, you decrease those problems. Another way you can reduce the number of handoffs is through automation and reorganizing teams. The automation gives the team members the ability to do work without depending or waiting on others. It could even eliminate parts of the process that would normally take a human to handle those things. So reorganizing your teams to provide the product directly to the customer rather than waiting for other people to do that can help with that as well. Okay, so the next part of flow is more of an introspective piece where you are constantly evaluating and looking at your processes, and you evaluate and determine where there are bottlenecks. Another way to call this is to call it a constraint. And Dr. Goldratt says here, in any value stream there is always a direction of flow, and there is always one and only one constraint. Any improvement not made at that constraint is an illusion. I wish I had a little bit better graphic here because that showed more than one constraint, because sometimes when we work on something that comes before the real constraint or after the real constraint, it's just an illusion in the sense that it's not really eliminating anything, because you've still got that main constraint that you have to deal with. So you're not really obtaining the benefits of reducing or eliminating those other constraints. So the main thing to do is identify the main constraint, and then you exploit that constraint. And what it means by exploit is to really make the best use of whatever that constraint is. You know what that constraint is, and so you maximize its benefit. So I wish I had a good example, but let's say you had a manufacturing process that you know you could only produce so many items per hour. Well, what you do is you produce that maximum number of items per hour to make use and exploit that constraint until you can figure out a better way. So that takes us to step 3, where you need to subordinate everything else to the above decisions. What that means is everything else is not as important as eliminating that constraint. So you focus on that to remove it. You elevate it, which is step number 4. You elevate it and make it very important so that you can do what you can to eliminate it. And in this process, you eliminate the constraint and then you go on to the next one once you've eliminated that. But you need to be careful not to allow the inertia of this process to cause a system constraint in and of itself. So, okay, let's move on. Part of the process of identifying and elevating these constraints, we've got a chart here that gives 4 potential constraints and what the problem with those constraints are and why it's a constraint, along with a countermeasure or what we can do to eliminate that constraint. For example, long wait times for production and test environments to be set up. That means the testers or even developers, as they develop a software piece, have to wait for these environments, and so they are slowed down and delayed in their progress. The countermeasure to this would be to create environments that are on demand, completely self-serviced, and always available when needed. Code deployment. Production code deployments take a long time. The way around this is to automate those deployments as much as possible, and to complete the automation, excuse me, by completing the automation process, it will allow developers to do deployments instead of waiting for someone later on in the process. Okay, the problem of test setup and run is similar to environment creation. Sometimes you need to set up test environments or test data, and that process may take too long. Along with that is the execution of regression tests, and especially when they're manual. And so what you need to do to get around that is to automate the testing, and then to parallelize the automated tests to align test and development rates. And the way that I look at that is to put those two things side by side and make sure that the rates are the same, development and testing, so that you're working at basically the same rate. Okay, this fourth one, overly tight architecture. Oftentimes in systems there are too many constraints or restrictions in the architecture. Sometimes this is with security or perhaps regulatory rules that you have. Some of them are unnecessary or overly strict, and one way around that is to evaluate those and determine which ones can be removed, and to create more loosely coupled architectures, facilitating safe changes with more autonomy. And a lot of these are just some examples, but the point is to identify and evaluate your systems and processes so that you can determine what can be changed and improved upon. This takes us to the next step, where we work hard to reduce or eliminate hardships and waste. Waste constitutes the largest threat to business viability, and by reducing hardships and waste, and by working smarter and changing habits that we have in the workplace, a continual process of improving ourselves, we can reduce waste and hardship and become more lean and more productive. And here are some examples and categories from our book. And this actually comes from Implementing Lean Software Development. Things such as partially done work, extra processes, extra features, task switching, waiting, motion, defects, non-standard or manual work, and heroics. Oftentimes in companies, workers will do what they can to make all these processes come together, and they'll stay up long hours or do things in a manual way that causes, it really takes too long. And if you can automate those processes and identify ways to be more productive, then that works out better. Some of these others are, I think, self-explanatory. For example, partially done work. I don't think any customer likes getting a product that isn't complete. Task switching decreases productivity. So these are just examples. There are probably many others that we can look at. In conclusion, the goal of the first way of DevOps is to improve and increase flow. And we can do this by making our work visible so that we can track it easier, limiting the work in process so that we're not trying to do too much at one time, and by focusing on those smaller pieces of work. This is reducing batch sizes, and then by decreasing the number of handoffs. So we do that through automation and reorganization. And by doing these things, we also must identify, evaluate, and eliminate constraints, waste, and hardship. As we do these things, then we will get increased flow. It'll be faster. Lead times will decrease. Our customers will be happy. We'll feel more productive, and things will go much better. Thank you very much for looking at our presentation. If you have any questions, please feel free to ask them, and I hope you enjoyed that, and good luck with your presentations as well. Thank you.